in to the YouTube channel of Gradeup. I'm Gourav Gupta. I hope all of you are doing well, and the students who are preparing for this year's CAT, they are like all their preparation are going properly. Okay, now I'm again here with some of the steps that will take you towards a good percentile score in QA section. And today we are going to take on a very basic method in which we calculate the unit digit of a number raised to the power any number using the method of cyclicity. All right. So friends, I welcome all of you, and let us start this session. Okay. Now, if I'll talk about the weightage of this particular topic, cyclicity to find the unit digit. So I can say that it is very rare in CAT. It is very rare to find the questions from this particular topic directly. But if you will understand this particular topic of finding the unit digit, then it will indirectly help you at a lot of places. All right. So let's talk about basics of calculating the unit digits. Now, what is a unit digit? Obviously, unit digit, we all know it is the rightmost digit of a number. All right. Now, if I'll not look at multiplications or let's say the powers of any numbers, if I'll not look at that, okay, I'll just straight away look at calculating the unit digit in any kind of calculation like addition, subtraction. All right. So what we do is, let's say if we are asked to find out the unit digit in this addition, 432 plus 687 plus 394 plus 735. So if we want to only find the unit digit in this calculation, so what we do is we just consider the unit digits of these numbers. Okay, so I will consider the unit digit of all these numbers 2, 7, 4 and 5, and will add all of them and will get my answer. All right. Okay, so this is how we get the unit digit in this simple calculation. There is no need to find the entire result. Just stay with the unit digits. So 2 plus 7 is 9. 9 plus 4 is 13. 13 plus 5 is 18. So 18, I'll just write 18 ka 8. Okay, so I'll just write 8 and hence it will be my answer. Okay. So if I look at the addition of these simple numbers and I am calculating only the unit digits, so I'll calculate the sum of all the unit digits and will write my final answer. All right, so this is very simple. But let's say if you have multiplication of some numbers, so 432 multiplied by 747 multiplied by 486 multiplied by 359. Okay, so you'll have to multiply these numbers and calculate and write the unit digit of the result. Okay, so again you will use the same method. So if in case we need to find out the unit digits, so I'll consider the unit digits only. All right, I'll consider the unit digits only. Okay, and we'll multiply these numbers. So 2 multiply 7 multiply 6 multiply 9. Now again you can save some time from here, so there is no need to calculate this result entirely. So you can again stick to the unit digits in all the calculations. So 2 multiplied by 7 is 14. Just keep 4 unit digit of 14. So just keep 4. So 4 now multiplied by 6 will give you 24. And again, I'll consider the unit digit only. Now again, 4 multiplied by 9 is 36. And hence the unit digit of my answer will be equal to 6. So every time I'm just keeping the unit digit into consideration and I am neglecting, I am just removing the remaining part of the number. Okay, so I take it once again with one more example. So let's say in the given multiplication, you will have to find out the unit digit. Okay, so the multiplication is 397 multiplied by 443 multiplied by 686 multiplied by 747. Okay, I have to multiply these four numbers and write the unit digit of the result. Okay, so I'll just consider the unit digits here: 7, 3, 6 and 7. So 7 into 3 into 6 into 7. That's it. So 7 into 3 will give me 21 and 1 as the unit digit. Then 1 multiplied by 6, the unit digit here will be 6. 6 multiplied by 7, it is 42. So 2 will be the unit digit of the final answer. All right. So this is just the basic thing that we need to understand while calculating unit digits. All right. So here we have just learned that in case you are looking to find out the unit digits in any kind of calculation, just stick with the unit digits in the question. So in the question, whatever numbers are there, just consider the unit digits and do the entire calculation. Okay. Now, the things are not that simple when you are considering the powers of some numbers. Okay. Let's say the number is 2 raised to the power 6. Okay. Now, right now I'm considering a very small base and a very small power. Now, 2 raised to power 6 is 2 into 2 into 2, and it can be written 6 times. So 2 multiplied by 2, how many times? 6 times. Now, if I want to find out the answer for this one, I can do this entire question manually. So 2 into 2 will give me 4. Again, 4 into 2 will give me 8. 8 into 2 will give me 16, and I'll retain the unit digit only, which is 6. Finally, again, 6 into 2 is 12, 2, and then 2 into 2 will give me a 4. So finally the answer will be 4. Finally, the unit digit of 2 raised to the power 6 will be equal to 4. All right. I could have calculated the result as well, because right now I have very small base with a very small power. Okay. Now what if the power is not that small? Here the power was 6. Now what if the power is 63? Okay. Now 2 raised to the power 63. I have to find out the unit digit of this calculation. All right. Now what can be done? Obviously, I cannot be calculating the unit digit in this case manually the way I have done in the previous case. Okay. So let's look at some logic. The logic here is called the cyclicity of unit digit. Okay. Now I'll be writing the unit digits of some of the powers of 2. So 2 raised to the power 1, the unit digit is 2. 2 raised to the power 2, unit digit is 4. 2 raised to the power 3, it is 8. 2 raised to the power 4, it is 6. Then again 2 raised to the power 5. Now 2 raised to the power 5, the value is 32 and the unit digit will be 2. 2 raised to the power 6, the unit digit will be 4. 2 raised to the power 7, it is 8. 2 raised to the power 8, it will be equal to 6. All right. Now, if you will observe in this case, 2 raised to power 1, unit digit is 2, then 4, then 8, and then 6. Now, after the unit digit of 6, the unit digits in the powers of 2, they have started repeating. So again, it is 2, 4, 8, and 6. Now further, if you'll write the next unit digit for 2 raised to the power 9, it will again be 2. For 2 raised to the power 10, it will be 4, then 8, and then 6. So this unit digits will keep on repeating. All right. So I can say that if I am looking at the unit digits of the powers of 2, they are showing some kind of pattern. Now pattern here is, after every fourth power, the unit digit is repeating itself. Okay. So you can see 2, 4, 8 and 6. Then again 2, 4, 8 and 6. 2, 4, 8 and 6. And it will keep on repeating in the same manner. And we can say that the cyclicity of the repetition of unit digits when we are considering the powers of 2 is 4. I'll repeat this statement. The cyclicity when you are looking at the unit digits of the powers of 2 is equal to 4. So after every fourth power, we can say that the unit digit will repeat in this particular case. I'm not generalizing this fact right now. I'm just saying that after every fourth power, the unit digit will repeat for the powers of 2. All right, simple. So I can say that if I'm dealing with the powers of 2, the cyclicity is equal to 4. All right. Now that means after every fourth power, the unit digit will repeat. So what you may do is, in order to save your time, look at the power. Here it is 63. Now divide this power by 4. Why by 4? Because 4 is the cyclicity here. So divide this power by 4 and write the remainder. Keep track of the remainder. So I can say that 63 when divided by 4, the remainder is equal to 3. All right. That means up till 60th power, up till 2 raised to the power 60, the unit digit will keep on repeating. All right. And the unit digit of 2 raised to the power 63 can be calculated by calculating the unit digit of 2 raised to the power 3. So whatever powers are up till 60, they will keep on showing the repetition because 60 is a multiple of 4. All right. Okay. So I'll just make some space. In case you have not understood, I'll write it for you. So if I'll keep on writing further powers of 2 in this case, okay, so after 2 raised to the power 8, if I'll keep on writing the other powers of 2, so 2 raised power 8 के बाद क्या आएगा? 2 raised power 9, 2 raised power 10, 2 raised power 11 and 2 raised power 12. So 2 raised power 12 will come at the bottom and again its unit digit will be equal to 6. Okay, so likewise if you'll observe at the bottom, all these powers are the multiples of 4. Likewise, 2 raised to the power 60 will lie at the bottom and its unit digit will be equal to 6. And if you'll write further powers, 2 raised to the power 61 will come at the top and will have unit digit of 2. 2 raised to the power 62 will have a unit digit of 4. And 2 raised to the power 63 will have a unit digit of 8. Okay, so I can say that 2 raised to the power 63 will lie in this row. Okay, so the unit digit of 2 raised to the power 63 will be same as that of 2 raised to the power 3 and that is equal to 8. All right, so I'll repeat this one. The original question was how to find out the unit digit of 2 raised to the power 63. Now to find out the unit digit of 2 raised to the power 63, I took help of the cyclicity of the unit digit whenever I'm dealing with the powers of 2. I could see that in this particular case where I'm looking at the powers of 2, the unit digit repeats after every fourth power. Okay, so hence I can say that the cyclicity of unit digit in the powers of 2 is equal to 4. Okay, so this is one thing that I have got. Okay, now since the cyclicity of the powers of 2 is 4, so just divide this power, which is a very high number, divide this power by 4 and keep a track of remainder. Just write the remainder. So 63 when divided by 4, the remainder is equal to 3. So 2 raised to the power 3, whatever unit digit you will get from here will be equal to the unit digit of 2 raised to the power 63 and hence in this case it is equal to 8. All right, I'll take one more example for the same base. So let's say you have 2 raised to the power 1735. Okay, 2 raised to the power 1735. Now you have to find the unit digit of this number. Now since we already know that the cyclicity of the unit digit for the powers of 2 is 4, so I'll straight away divide 1735 the power by 4 and will calculate the remainder. All right, now remainder in this case is equal to 3 once again. So your answer will be 2 raised to the power 3. Calculate the unit digit and it will be equal to 8. Okay. One more quick question just for a better understanding. 2 raised to the power 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 2 raised to the power 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, the logic will remain same. I'll consider the power. We'll divide it by 4 and we'll calculate the remainder. Okay. Now, if all of you remember the divisibility rule of 4. Now, divisibility rule of 4 क्या होता है? Yes, anyone? Divisibility rule of 4. So, divisibility rule of 4 is you just need to check the last 2 digits of the number. Okay, so I'm making life further easy for you. So there is no need to consider this entire power because in this case we are dividing it by 4. So there is no need to consider the entire power. Just look at the last 2 digits of the power because this is the divisibility rule of 4. So 89 when divided by 4, the remainder is equal to 1. All right. So the entire power when divided by 4 will give you the same remainder. Okay. So now you may write it as 2 raised to the power 1 and that is equal to 2. So 2 will be the unit digit of this calculation. All right. Okay. Now one very important point that you should be knowing. Now let's consider this example to understand the important point that I'm talking about. Now, let's say I have the question as 2 raised to the power 1396. Okay. Now what I'll do is I'll divide the power by 4 and we'll check the remainder. Now in this case you will observe that the power is completely divisible by 4. Okay. So the important thing is whenever the power is a multiple of 4, I'll go back. So whenever the power is a multiple of 4, let's say 60. Okay, whenever the power is multiple of 4, let's say 60. So we can say that the unit digit here is decided by this number, which is 2 raised to the power 4. Okay, so the important point here is whenever the power is a multiple of 4, we'll not write the remainder, but we'll write the power as 4 only. So instead of calculating the remainder in this case, we'll directly write the power as 4. But this can only be done if the power is a multiple of 4. Okay. So if the power is a multiple of 4, then write the power as 4. Now 2 raised to the power 4, it is 16 and the unit digit is 6. And hence this is the answer as the unit digit of 2 raised to the power 1396. All right. Okay. So let's review whatever we have done till now. We have just taken the base as 2. Okay. And we are calculating the unit digit of any power of 2 by using the method of cyclicity. Now we have understood, we have obtained that the cyclicity of unit digit whenever we are dealing with the powers of 2 is 4. So cyclicity here is 4. Okay. And hence to calculate the unit digit of any power of 2, what we'll do is we'll divide the power by 4. Okay. We'll divide the power by 4 and write the remainder as the power. Okay. Also, in case the power is a multiple of 4, so instead of writing the remainder, we'll write the power as 4 only. Okay. So this was how to deal with the powers of 2. Now, if I have any other base, the logic will be exactly the same. Okay. So we'll spend a few minutes in calculating the cyclicity of some of the bases. Okay. Now, if I'm talking about 3, if I'm considering 3, now 3 raised to the power 1 is 3. 3 raised to the power 2, the unit digit is 9. 3 cubed, the unit digit is 7. And 3 raised to the power 4, unit digit is 1. After which it will start repeating 3, 9, 7, 1. and so on. So I can say that the cyclicity, so when the base is 3, cyclicity is 4. Okay, for base 2 we have already seen the cyclicity. For base 3 the cyclicity is 4. When base is 4, let's look at the cyclicity. So 4 raised to the power 1 is 4. 4 square is 16. I'll write 6. 4 cube is 64. Again, I'll have 4, then again 6, 4, 6, and so on. Now here, in this case, the unit digit is repeating after every second power. So I can say that for 4, the cyclicity is 2. All right. Now similarly, the cyclicity for 5, 5, 5, 5. So for any power of 5, the unit digit remains 1. Sorry, the unit digit remains 5. So I can say that the cyclicity for 5 will be equal to 1. All right. Now, likewise, you can calculate the cyclicities of all the bases up till 9. Okay. And that's it. Now you can find out the unit digit of any number raised to the power any other number. So I'll help you. So on this slide, I have mentioned the cyclicity for all the unit digits. Okay. So if in the base I have a unit digit of 0, its cyclicity will be 1, because if the unit digit is 0, so 0 raised to the power anything, it will keep on giving you 0 as the unit digit. Now, whenever you have 1 as the unit digit raised to the power any number, every time you will obtain 1 as the unit digit again. So again, in this case, cyclicity is 1. All right. Okay. Now, if unit digit is 2, cyclicity is 4. We have already seen unit digit is 3, the cyclicity of 4. Unit digit of 4, cyclicity 2. For 5, it is 1. For 6, it is 1. For 7, so for 7, if I'll write all the unit digits, so 7 raised to the power 1, 7 square, 7 cube, and 7 raised to the power 4. So 7, 9, 3, 1, and after which it will start repeating, and again 7 will appear. All right. So for 7, the cyclicity for unit digit will be 4. For 8, 8 raised to the power 1, 8 square, 8 cube, and 8 raised to the power 4. These are the unit digits, and then again 8 will repeat. So I can say that for the powers of 8, the cyclicity for unit digit will be again equal to 4, and for 9 it will be 9, 1, 9, 1, and so on, and hence the cyclicity of 2. All right. So I believe all of you now understand how to basically calculate the cyclicity. All right. Now, if you look at this entire table, you will observe that we have different cyclicities for some different unit digits. So there is a cyclicity of 1 present. There is a cyclicity of 2 for 4 and for 9. Okay. And the remaining numbers 2, 3, 7, and 8. These numbers have a cyclicity of 4. Okay. Now, it's totally up to you if you want to learn the cyclicities of all these numbers. Okay. If you want to cram these numbers, or whenever the question will appear in the examination, you will calculate the cyclicity, or you will do enough practice that you will remember the cyclicities of all these numbers. Okay. I'm against all of these, right? So let's see what can be done now to make life again a little easy for all of us. Okay, let's have a look at it. Now I'll consider this number and its cyclicity, which was 2. So cyclicity of 4. So I'll just write the unit digits: 4, 6, 4, 6, 4, 6, and so on. Okay, so I can clearly see that in case of powers of 4, the unit digits are repeating after every second power. 4, 6, 4, 6, 4, 6, and so on. Now, if they are repeating after every second power, can I also say that they will repeat after every fourth power? I look at the repetition of 4, 6, 4, 6. and then 4646 and so on. Okay, I'll repeat it again. For the powers of 4, the unit digit is repeating after every second power. So it is 4, 6, 4, 6, and then 4, 6, 4, 6, and so on. Okay. Now, instead of looking at the repetition after every second power, I'll consider the repetition after every fourth power. So I'll make the groups of 4, 6, 4, 6, 4, 6, 4, 6, and so on. Okay. So instead of considering the cyclicity of 4 as 2, I can also consider the cyclicity of 4 as 4. Okay, just to reduce some burden. Okay, though obviously the cyclicity of the unit digits for 4 is 2, but I can also consider it as 4. A similar thing can be done for 9. Okay, so the cyclicity of 9 is 2, where the unit digits were repeating like 9, 1, 9, 1, and so on. All right, so I'll consider this as a single group. So 9191 and then 9191 and so on. So cyclicity of 9 can also be considered as 4. All right, now the remaining numbers 0. So in case of the powers of 0, the unit digit will always remain 0. So that means unit digit is 0, 0, 0, 0. It is repeating after every number, every power. I'll make a pair of 4 and can say that the cyclicity of unit digit of 0 can be taken as 4 as well. Same thing can be done for the remaining numbers. Okay, so you can always say that the unit digit for any base raised to the power any number will definitely repeat after every fourth power, and it will happen for all the bases. Okay, so you don't have a burden of remembering the cyclicity for each and every base. You may consider the cyclicity of all the bases as 4. Okay, so now you don't need to calculate the cyclicities. You just keep in mind that you may consider the cyclicity of all the numbers as 4. So what you need to do is, whenever you have a question, then just first of all, just as the first step, divide the power by 4 and write the remainder. Okay, so this step will remain constant in every case. So let's take a question. So let's say the question is, need to calculate the unit digit of 7 raised to the power 486. All right. Now, no need to check the cyclicity of the unit digits of 7. Okay. Just look at the power, which is 486, and divide 486 by 4 and write the remainder. So 486 when divided by 4, the remainder will be equal to 2. So hence the unit digit of 7 raised to the power 486 will be same as the unit digit of 7 raised to the power 2. Okay, 7 raised to the power 2 will end with 9. So 9 will be the unit digit of 7 raised to the power 486. All right, am I clear? Now taking on one more question. Let's say the base is 3697 and the power is 24935. All right. Now, as a simple logic, what we need to do is we just need to consider unit digit in the base. Okay, so the unit digit of 3697 raised to the power any number will be same as the unit digit of 7 raised to the power 24935. Okay, now since the cyclicity of 4 is clear, so we need to divide the power by 4. All right, now I'll apply the divisibility rule of 4, which says that in order to check the number's divisibility by 4, we just look at the last 2 digits. Okay, so again, the entire power is not useful. Just retain the last 2 digits of the power. All right, So if this was the original question, now I have changed the question to this, which looks simple, which looks convenient. Okay. So the unit digit of 3697 raised to the power 24935 will be same as the unit digit of 7 raised to the power 35. Okay. Now 7 as it is, 35 when divided by 4, the remainder is 3. Just write the unit digit of 7 cube. As a part of the preparation of CAT, you should also be remembering the value of 7 cube. Okay, never mind, just write the unit digit. It will be equal to 3. Okay, fine. So the unit digit of 3697 raised to the power such a big number is equal to 3. All right. Okay. Now finally, one more question. So let's say you have 4 raised to the power 2392. So here the unit digit will be 4 raised to the power. Now 2392, I need to divide it by 4. Just check the last 2 digits, it is 92. Now I can see that 92 is completely divisible by 4. So the important thing that I have told you, the important note that we have made earlier, whenever the power is a multiple of 4, we will write it as 4 only. Okay, so just calculate 4 raised to the power 4, the value of 4 raised to the power 4, or no need to find the value, just find the unit digit. So unit digit here will be equal to 6. All right, so friends, that's it about unit digits. That is how we calculate unit digits of any base and any power. All right, I'll come up with some difficult questions which are based on unit digits in a few days. All right, so wait and watch all the sessions which I'm coming up on YouTube. Okay, right now I'm just covering all the basic concepts which are required for some people in order to basically boost up your percentile score. Okay, we are basically not even clear about the basic concepts in quant. Okay, so this is why I have developed this series, so that I will put stress on all the basic concepts which we generally leave or cram. All right, so that's all from my side. Now, in case you want regular updates of my upcoming sessions on YouTube as well as on our Gradeup app, so in case you want the regular updates, here is my number. So you may note down my number and send me a WhatsApp which includes all these details of yours. All right, I'll add your number in the group on which in which I send regular updates, and you will not miss any kind of session which I'm conducting like this. All right, okay, now this is basically the schedule of all the YouTube sessions that we are conducting in this week. So you may take a picture of this schedule and you will not miss even any lecture of QA, DI, be it verbal RC, be it daily editorial that we conduct at 10 a.m. Okay, so you'll not miss any such session from now onward. Now, some important details about the sessions that you may avail. Uh, Generally, you will have a problem of searching for different topics on YouTube. Okay, and we generally waste a lot of time in doing that. Now, here we have introduced one thing where you can find all the free lectures at one place. All right. Now, look at the description of this session and you will find a link. And if you'll click on that link, it will redirect you to a sheet where you will find all the topics of all the sections at one place. Just click the link in front of that session and it will redirect you to the session automatically. All right. Okay. Now, the next thing is like a flat 50% off, which is currently going on. And I believe today is the last day to avail that discount. So you can join any of the courses that we are offering on our app and you can avail this discount. This is the update. This is one of the detail about the batch which we have launched on 13th of August. This batch is a CAT21 percentile booster batch, and below is the details of all the faculty members who are teaching in this batch. These are the details for CAT22 and the SNAP, NMAT, CMAT, and TISNET batches that we run. So you may take a snapshot of this. This slide has all the details of the courses and the batches that are currently going on. So this CAT22 batch is already launched on 4th of August, and this batch for SNAP and Maths, CMAT, and TestNet we are going to launch in 1 or 2 days. So all of you may enroll for whatever courses that you want to. And these are the different courses that we offer for CAT and other MBA entrance examinations. This is the list of mentors that we have other than me. So I'm Gaurav Gupta, and this is the list of mentors. The super subscription plans that we offer for CAT21 and CAT22 and the other entrance examinations. Now, the details covers all the examination that are covered under these courses. Okay, the validity of each and every plan and the inclusions of all this entire course. Now we have a mega mock challenge for all the students who are appearing for MHCT examination. Okay. Now this mega mock was live and it will come back again. Okay. So this is available till 23rd of August day end. So please take this challenge as you will get yourself evaluated on all India parameters. Now if you like this session, please comment, share, and subscribe, and also do press the like button. I'll keep on coming with such sessions in which, like, I'll take up a very small topic and will throw light on that topic. That's all from my side, friends. Thank you very much. We'll see you the next time. Have a good day. Bye bye.